Hello everyone! Thank you for watching our video. We are a computer science students from Imam Abdurrahman bin Faisal University in Dammam. Today, in this video, we are going to introduce an abstract to our project for a parallel architecture course that talk about Sudoku puzzles in parallel implementation. First of all, what's Sudoku puzzle? Sudoku puzzles are those cool number grids we all love to solve, which consists of 9 by 9 grids, each of them divided into 9 3 by 3 subgrids. To solve it, we have 3 main rules. We need to consider that each row, column, and subgrid must contain the number from 1 to 9 and without any repetition. As we know, to solve these puzzles, we need to solve one step at a time. But what if we could solve many steps at once? That's exactly what we explored in our projects. In our talk, we will look at how traditional Sudoku solving works and compare it to the new way of doing it with the parallel computing. Parallel is like having a team of people working together to solve different parts of puzzle all at the same time. We will show you how much faster it can be. But of course, we also faced some challenges along the way, like something called the race condition. So, our project covered 3 main parts. First, how sequential solving implemented. Second, how parallel solving implemented, and how we solved the race condition that we faced in our code. Lastly, comparing the performance for parallel implementation against the traditional sequential approach. Keep watching this video to cover all these parts.
So I'm Kadi Shamri, and we will talk about Sudoku puzzle using a sequential implementation. So here the sequential execution for the Sudoku. So we get solved Sudoku with this execution time, which is 0.0025 puzzle per second. So what we can do to speed up the time?
Finally, we come up with the concept of parallel to speed up the program. As you all know, the parallel is a type of computing architecture in which it can execute independent tasks of a program at the same time. So we convert our sequential code into parallel. After we implemented the code, we faced a race condition that caused wrong outputs. So now you may be wondered, what is the race condition? Race condition basically is an undesirable situation that occurs when a device or system attempts to perform 2 or more operations at the same time. But because of the nature of device or system, the operations must be done in the proper sequence to be done correctly. Here, as you can see, the solution found is global variable. It's declared at the top of the code. So here, multiple threads within a critical section could access and modify it. So we add pragma OMP critical to ensure the race condition problem is solved. Here in the second output, it shows the printed puzzle with the wrong order, and it's an unpredictable order. That's mean every time we run the program, it will give us different order. So we solve the race condition by adding pragma OMP critical directive around the printing section to ensure that only one thread accesses and modifies the print function at a time. Here you can see the solved Sudoku with the execution time for the first output, and here for the second output.
Okay, so here sequential and parallel execution time. So here we have comparison between the execution time in parallel versus the sequential implementation of the Sudoku problem. So here, first of all, the sequential implementation demonstrate commendable performance with the average execution time of 2.044 millisecond per puzzle. So this reflects the efficiency of single-threaded execution model, which is sequential implementation to solve a Sudoku problem. So actually, sequential implementation solves that challenge quickly and reliably. And versus the parallel implementation, which actually shows impressive average execution time of 1.2 milliseconds per puzzle. And this significant speed shows the advantage of using parallelization while solving a Sudoku problem. Actually, here in parallel implementation, we're utilizing multiple threads to concurrently explore the puzzle space, which is we will explore the solution faster than sequential implementation.
Thank you for watching our video.